Good morning.
So what is it?
Good
Why only
Morning, sir.
70 students are joined because the
morning,
class
sir.
test?
Sir, actually, sir, this week we had a lot of assignments and all. Sir, could you please postpone the test to next week?
No, no, no. Next week maybe I will have some other work. Then it will be difficult for me to
Sir,
take the class test.
sir, actually this week we are every Indian yearly we have an assignment due and all. And
But
sir,
I have fixed up long time back.
yes,
Please,
sir,
sir.
last week you said, but actually suddenly we got our
Yes,
assignment.
Sir, please, sir, just this time. The internet connection is not also available
Hello,
in some
sir.
areas.
Hello, sir. Internet connection is off due to
Yes, sir.
Madhyamik
There.
exam.
Madhyamik exam.
Yes, sir.
Sir.
Yes, sir.
internet connection is after 11. Before that it will be finished. It is only for half an hour.
Sir, actually, we had a lot of assignments pending, and we had a lot of assignments to do. So none of us are fully prepared, sir. That's the issue, sir, because we didn't have time.
Then why you did not inform me in the earlier that
Sir,
in
Sir,
the
sir,
when I
actually,
yesterday
announced it?
we, sir,
Sir, we have
yesterday
a
we
private
informed
emergency.
in the Google
No, no,
Classroom, but
not yesterday. Not yesterday. Last week, before the midterm exam, I told you that I will take them.
yes,
And
sir,
it
but
is
you
in
fixed
the
the date of the test actually last week, I think so.
last
So,
week. But
yes, sir.
then you did not
Yes, sir.
mention anything that you
So,
have lots of work.
yes, actually, we did not real. We thought that we will study and all, but suddenly lot of assignments they were due, and actually we could not contact you because we did not have your number or like your email ID. We did not have. So we tried to inform in the classroom, but then I think you didn't see.
And it is not any logic. So what I will do? If I could not take the exam, then I don't have any responsibility. I am mentioning that. Suppose I would have some other work, I could not able to take the class, then it will be difficult. Also, I have to check this 100 answer script, then what will happen?
So,
Sir,
but
could
as
you
of now, many
please
of us
take
aren't prepared for the test. The load was too much, and we have our vivas and our assignments are due like on a daily basis.
No, then you could have asked the other teachers that we have already class test and to change their schedule.
Sir, actually, we
Because
thought offline classes will start, but then this
Yes,
our
sir. We
offline
received
classes
a
are
new notice that
postponed suddenly. So everything will
online
be
semester
online.
will be there.
That's the problem, sir.
so there are 4 weeks left for the reopening
Sir,
of the
sir, after like
campus.
any day you say like any convenient day you want, we can
Yes,
like
sir.
give.
Any day, anytime you
Yes,
want, sir.
sir.
Yes,
We
sir.
can.
Yes, sir. The final semester
Even
have been postponed. Previously, it was from 7, and now it is from 18 April.
so next week, whenever you are free, just inform. We'll be
So, like we
available.
have 4 more weeks of classes left. So, on any one of that, you can take the test.
then again, I have to check what I will teach today because I thought that I will take the exam, then I will decide what we will discuss.
So, actually, there was no means to contact you earlier. Like we tried mailing and
Everybody
using
contacting
the
me.
Google
Why
Form.
you could not contact me? I given the phone number in each classroom. usually teachers do not give, but I always give my everything so that students can contact because it is in online mode.
Sir, share contact
Okay, so
please in the GPU.
what I have discussed in the last class.
Multiple integrals.
Yes, sir. Multiple integrals.
Okay, then I will join 10 minutes later because I will join through my tab. It will take 10 minutes to discuss the topic.
Yes, sir.
Okay,
Yesterday you were teaching double
Okay, sir,
integrals.
no problem.
okay, I will joining 10 within 10 minutes. Wait.
Okay, sir.
Okay.
Thank you.
Thank you.
Uh,
Sir.
Hello, I am audible.
Yes.
Yes, sir.
Yes, sir.
This one I think I have discussed, no?
Yes, sir. This part discussed, sir.
Yes, sir.
This part discussed. This Jacobian, Jacobian transformation of variables and evaluation of Jacobian discussed. Change of variables in double integrals.
Yes, sir.
Okay.
Yes, sir.
And
Jacobian is
also,
discussed.
yes,
So Jacobian is discussed.
discussed. And the change of order of integration.
No, sir. This part not.
Change of order of integration is not discussed. Okay. So, as I told you that sometimes we may use the transformation of variables to evaluate the double integral. Suppose sometimes we consider that x equal to some say u plus v, y equal to u minus v. Why we give the transformation? It becomes easier to evaluate. But as I told you that for the transformation of variables, as here we are considering two variables, maybe later three variables, uh, then we have to evaluate the Jacobian of the transformation, and dx dy actually the mod Jacobian into du dv. And if say x equal to r cos theta, y equal to r sin theta is the transformation, you know that already I have discussed the Jacobian is r. So dx dy equal to r dr d theta. Also, sometimes it is found that the change of order of integration is also very important. Change of order of integration means suppose the one integral is given, say fxy dx dy. Here, say for example, first x, then y. That is x varies from certain limit to certain other limit, y varies from to this. Sometimes it is happened that first with respect to x may be difficult to evaluate. It is better if we integrate first with respect to y. In this situation, we will change the order of integration. That is, we will do first with respect to y, then with respect to x. This is there is no difficulty if x equal to say for example a to b, y equal to c to d. That is, if both a, x and y have independent limit, constant limit, then whether you are taking first with respect to x, then with respect to y, or first with respect to y, then with respect to x, it does not matter. It matters when one limit is a function of the other variable. Suppose here, suppose here, suppose here,
say x equal to phi y to psi y, then y equal to c to d. In this case, here x is a function of y, so you have to evaluate first with respect to x, then with respect to y, because y limit is constant, but x is a function of y. But the function, this integrand, is in a form that is very much difficult to integrate first with respect to x. It will be easier to integrate first with respect to y. In that case, we can change the order of integration, but the limit will also be changed. And what you have to do, that first you have to draw the functions x equal to phi y, x equal to psi y equal to c, y equal to d. That is, you have to sketch the region of integration from which again you can give the limit of x, limit of y from the region. That is sometimes very important. Also, it is happened that even there is no need to change the order of integration. First, with respect to x is integrable, and then y is also no problem. But if your question it is given that change the order of integration, then evaluate it, then you have to change the order of integration. And in this context, one example is given here, how you will change the order of integration. Here, look at this. Evaluate R over the region R fxy dx dy, where fxy equal to xy and R is the region bounded by the two axes and the line x plus y equal to 1. So as I told you that if you would like to change, here nothing is given that you have to change the order of integration, or the integrand is a function such that it will be difficult to integrate first with respect to y or first with respect to x. The it is integrand also very simple, into x into y. The region of integration is also simple, x-axis, y-axis, and the line x plus y equal to 1. In this type of cases, it is not necessary that you have to change the order of integration. Also in the question also it is not given that you have to change the order of integration. However, if it is mentioned in the question that change the order of integration, then you have to change the order of integration. This is number one. Number two, sometimes it is given that evaluate this r fxy dxy, evaluate first with respect to x, then with respect to y, again first with respect to y, then with respect to x, and verify that both are equal. Then you have to change the order of integration, and you have to evaluate both, and you have to check whether the both integrals are same or not. Here, the example is, look at this. Here the function is fxy, simple function. First, you have to set the limit. Here the region is R. R is the region, this shaded region as shown in the figure. This point is 1, 0, this is 0, 1, and this line is x plus y equal to 1. So first, if you do first with respect to y, then y varies from any point on this line to any point on the line x plus y equal to 1. So here y varies from 0 to any point on the line. Any point on the line means 1 minus here x plus y equal to 1, that is y equal to 1 minus x. So here y equal to 0 to 1 minus x, xy dy first with respect to y, then with respect to x, and x varies from what? X varies from 0 to 1. 0 to 1. X varies from 0 to 1. So here first integrate with respect to y, that is y square by 2. So after substituting limit, it is 1 minus x whole square by 2 dx, and then evaluate this integral with respect to it is a simple function, and that the value is 1 by 24. Now the same integral, if you would like to change the order of integration, or you need to verify that after changing the order of integration also gives the same value 1 by 24 or not, then you have to do what? You have to do the change the order of integration. What is the then what will be the limit for that after changing the order of integration? In that case, you will do first with respect to y, then with respect to, sorry, first with respect to x, then with respect to y. So if you do first with respect to y, your x varies from here to here. So what will be the x limit? X from 0 to any point on the line x plus y equal to 1. That is, x varies from 0 to 1 minus y, and y varies from 0 to 1. So look at this. Here uh, r fxy dx dy equal to x varies from 0 to 1 minus y varies from 0 to 1, xy dx dy. Then what? First with respect to x, so y is a constant, so x square by 2. Then its limit 0 to 1 minus y, so it is 1 minus y square by 2. Then evaluate it, it is 1 by 24. So one thing you must remember that if you need to change the order of integration, whether it is given in the question, whether you think that if we change the order, or then it will be easier to evaluate, whatever may be the region, it is necessary to draw the region of integration. Then only it is possible to uh, uh, set the new limit, because if you do not draw the figure, then it will be difficult for you to set the limit after changing the order of integration. Remember that is given here, that to change the order of integration, first draw the region of integration R, and then change the order of integration from the pictorial representation of the region R. Remember this. Okay, next another example. Evaluate R y dx dy, where R is the region bounded by x axis, y axis, and the portion of the circle x square plus y square equal to 1 in the first quadrant. So here it is x square plus y square equal to 1 in the first quadrant. This is a circle. So we are considering a portion of the circle in the first quadrant. That is as shown in the figure, the shaded region. Here is the region of integration. And the function is very simple, which is y. Fxy is y. So here you can do it in two ways. You can solve this integral in two ways. Number one, you can give a transformation, because it is a circle, x square plus y square equal to 1. So if you give a transformation, usually we know that in case of circle with center at 0, 0, we prefer to give the transformation x equal to r cos theta, y equal to r sin theta. Hello? Hello, I am audible?
Yes,
Yes,
sir, you
sir.
are audible.
Yes, sir.
Okay. So here x square plus y square equal to 1, the circle center at 0, 0 and radius is 1. So usually we In case of circle, we prefer to give the transformation this. You, even if you do not, I will show you, even if you do not give the transformation in this case, then also it is possible to evaluate this integral without giving the transformation. But it becomes easier if we give this transformation. Why? Look at this. If you give the transformation x equal to r cos theta, y equal to r sin theta, then you know that this Jacobian is r, and this integral becomes, look at this, at any point on the circle, if this is theta and this is r, then since we are considering its portion in the first quadrant, so theta varies from 0 to pi by 2, and r, since its radius is 1, r varies from 0 to 1. R varies from 0 to 1. This. And y equal to what? R sin theta, and dx dy equal to what? R dr d theta. So it is r square sin theta dr d, and its value is just 1. Now, someone of you may ask me that if we don't give the transformation, is it possible or not to evaluate the integral? Yes, without transformation also it is possible to evaluate, but sometimes this, for this problem it is not so difficult, but in some problems it may be difficult without giving any transformation. For this example, suppose you are not giving this transformation. You are not giving this transformation. Then what will be the limit? What will be the limit? This integral r a y dx. So if you do first with respect to y, then y varies from what? Y varies from, suppose you are choosing y day first, then x. And if you choose x first, then also you can do the same thing, but your limit will be different. Okay. So if you do first with respect to y, then y varies from what? Y varies from 0 to, on the curve. On the curve means here circle. So y varies from what? Y square equal to 1 minus x square. So y equal to root over of 1 minus x square. 1 minus x square. And x varies from 0 to 1. X varies
1.
from 0 to 1. And y dy dx. So sorry, first with respect to y and then with respect to x. So it is y square by 2. Y square by 2 means 1 minus x square by 2. That is a square root, 1 minus x square by 2. Then it will be a function of x. You can integrate with respect to x, and x equal to 0 to 1. It will give also the same thing, 1 by 3. So even if you do not give the transformation, you can do it. But uh, sometimes it is given just to check whether you know everything or not, that give a suitable transformation and evaluate the integral. Then the suitable transformation means you have to consider this transformation. And even if you do not like to integrate y first then x, then also it is possible. Then also it is possible. Then what? Then what? This means x first, y second. Then x varies from what? X varies from 0 to root over of 1 minus x square. X 0 to root over of 1 minus y square. And y varies from 0 to 1. Y dx dy. That is, it will be xy, because you are doing first with respect to x. X equal to what? root over of 1 minus y square, that is y into root over of 1 minus y square, then integrate with respect to y. This y into 1 minus y square, you have to evaluate. So it is possible with a suitable transformation. It is possible with the change of order of integration without giving any transformation. So it all are depends on your problem. If problem is such a way that it does not matter whether I will give a transformation or not, whether I will change the order of integration or not, then you can do anything. If nothing is given mentioned in your question, if mentioned, then you have to do accordingly. So, do you have any question?
No, sir.
Okay, then I will show you another thing. Then I will show you another thing. And then some more examples. Okay. First, try to read the problem. Then I will discuss. Try to understand by yourself that I have discussed. Whether you will give the change. First, what is the given integral? Number one. Then the region of integration. Here, look at this. The region of integration is here. The region of integration is the ellipse, and in the first quadrant. So first draw the ellipse with center 0, 0, and in the first quadrant. So the shaded portion. And then what? Then you have to check whether you will move with the change of order of integration or not, because nothing is given here. Then you can check whether you will give any transformation or not. So that is given here. You can check. And if you have any question, you may ask me. And also here it is transformation is given x equal to a r cos theta, y equal to b r sin theta. Even without transformation also you can evaluate it. So first try to understand what is written here and why I have considered this transformation. Hello, this transformation is clear. Why I have given this transformation?
Yes, sir. It is.
Yes, sir.
Yes, sir.
Okay. Actually, two steps done in one step. Because what it is actually it is done, that this is the circle, this is the ellipse, x square by a square plus y square by b square equal to 1. So if you give a transformation x equal to a u, y equal to b v, then it becomes what? U square plus v square equal to 1, and dx dy equal to what? Dx dy equal to, if you prepare a Jacobian, then it will be ab du dv. So dx dy, and your ellipse will be what? U square plus v square equal to 1. It is what? It is a circle
Sir,
with
it is
center at
circle.
0, 0, radius 1. So you can give u equal to r cos theta, v equal to r sin theta. In that case, its Jacobian will be what? R, and du dv equal to what? R dr d theta. So look at this. If you give this transformation together, then it becomes ABR. Here look at this. Here AB, here R. So ultimately you will get ABR dr d theta. Same thing we will get here, but in a single transformation. That means that it first reduced to a circle, then after giving this transformation, and then giving the this transformation u equal to r cos theta, v equal to r sin theta, it becomes it moves to the polar coordinates. This one, it is easier to evaluate. So this transformation v a r cos theta, v r sin theta actually cover the two steps in one step. And if anyone asks me that if I don't like to, if I do not give the transformation, is it possible to evaluate? Then also possible. Suppose, for example, here R, if you do y first, x second, then y varies from what? This to this, from y equal to 0 to root over of y square by b square equal to 1 minus x square by a square. So y equal to what? Y equal to b into root over of 1 minus x square by a square. So b into root over of 1 minus x square by a square. And x varies from 0 to a, x varies from 0 to a. Then also you can evaluate, because it is y square only, y square, not y square, y dy dx, y square by 2. So it will be a square of this. So it is easier to evaluate also, no problem. But it depends on your choice. Depends on your choice. If you would like to give the transformation, if you can give it. If you would think that no, it is not necessary to give the transformation, it will be easier to evaluate if we do the integral directly, then you can do it. But I would suggest you first check this integral. Here it is y only, so for this case it is no problem. But this function is different and a little more complicated, then I would always suggest you to give the transformation, then move, then move. Otherwise, there is a root 1 minus y square by x square, 1 minus x square by a square. If there is any function, say for example, y to the power 5, then it will be 1 minus x square by a square, or then to the power 5, then it will be difficult to evaluate the integral. Otherwise, you can do it, no problem. So this is one example, and next one is try to understand this. What I have written here, first try to understand it, then I will explain. This region of integration is very important. Try to first find the region of integration. Check whether it is if you got it or not, then I will explain it. Yeah, Kiran? Okay. So, so here the function is very simple. Only y, but the plane bounded by y equal to x. This line, this is y equal to x, and the parabola y equal to 4x minus x square, and this parabola is this, and the region is bounded by these two curves, that is this one, and here this intersecting point is 3 3. So if you first here the integral region R, first you have to set the limit. Limit is what? If you consider, say y first, as I have done here, y first, then y varies from where? From from so from any point on this line means y equal to x, and any point on this parabola. So here y equal to x to 4x minus x square, y equal to x to any point on this line to any point on the parabola, that is y equal to x to 4x minus x square, and x varies from what? X varies from 0 to this point, this is what? 3, so 0 to 3, then this one nothing, so 54 by 5. So if you can place the region of integration, then it is not so difficult to give the limit for the variable. Otherwise, it will be difficult, and sometimes it will be wrong limit for the variable. Remember that. So first try to draw the figure. Even if you made some mistake in this step, you will get certain marks if you draw the figure, because as you have understood what is the region of region of integration. So this is one thing. And next, the second one, look at this. Here it is 0 to x, 0 to 3 dx dy. So if I consider this limit, nothing is given, that which one is y limit and which one is x limit. Could you tell me which one is x limit, which one limit is for x and which one limit for y?
2x for y.
Huh?
0 to x is y.
0 to x is y. 0 to x is y. So this one here it is nothing given, but you have to understand that y equal to 0 to x and x equal to 0 to 3, because one variable in terms of the other variable. Y equal to 0 to x, and then you have to evaluate first. Here it is given first x dx, but actually the first integral will be dy. So that's why it is changed dy then dx. Then it is nothing. Few minor things you have to remember. Otherwise, if anyone start to do the integral first with respect to, since here it is given x uh, first, so anybody start to do the integration first with respect to x, then it will be difficult because it will be a mistake and you will not find the value. Though here it is given in this way, you would understand that you have to do first with respect to y since, and this limit is with limit of y. Okay, this is one thing. Okay, so I will continue or you will take 10 minutes break.
Sir, whatever you want, sir.
Today, do you have any other assignment or class?
Yes, sir.
Yes, sir. Yes, sir.
Today, do you have any other class test assignment or anything? Then I think that I will finish and I will leave earlier so that we can
No,
do
sir, you
other
can
things.
continue, sir.
Okay. Okay, so next class I shall take the class test, and then I have decided that it is almost the multiple integral will be finished today, and then
Okay,
we
sir.
will discuss some other problems on that topics that I have discussed earlier.
Okay, sir.
Okay, try to first problem. Try to look at the first problem. Find the value of 0 to infinity, 0 to infinity. Here also you have to understand which one is x limit, which one is y limit. E to the power minus x square, e to the power minus y square dx dy. So if you do not check this portion, just look at this portion. Uh, just look at this portion only. Here, first you will observe that both the limit are constant limit. So since constant limit uh, and here look at this, e to the power minus x square into e to the power minus y square. So x and y are separable, limits are also constant. So it can be written in this way: 0 to infinity e to the power minus x square dx into 0 to infinity e to the power minus, sorry, just a moment, e to the power minus x square dx into 0 to infinity e to the power minus y square dy. Why? Because limits are independent and also the function is separable. In sometimes this integral is given in this way: 0 to infinity, 0 to infinity e to the power minus x square plus y square dx dy. So if it is given in this way, and if it is given in this way, sometimes you will sometimes you will get difficulty to that here the function is given in this way, and in that case you will do it first with respect to x or first with respect to y. Even though the limits are constant limit, still it will be difficult for you to get idea that you will do it first with respect to x or first with respect to it, or what you will do, how you will integrate. It is given in this way, then you can, but you have to remember that e to the power minus x square plus y square means e to the power minus x square into e to the power minus y square. Then it is easier to you. But if the integral is given in this way, then at first look, it will be difficult for you to how you will proceed. So uh, that's why I am discussing all possible ways so that uh, it becomes easier to you evaluate. So even if it is given in this way, you can do it. Okay. Anyway, next, how to evaluate the integral? Do you know the beta gamma function? Hello.
Yes, sir.
Yes,
Zero
sir.
to in 0 to infinity e to the power minus x, x to the power n minus 1 dx. What is the value of this integral? Do you know this integral? 0 to infinity e to the power minus x, x to the power n minus 1 dx. This is what? This is actually gamma function, gamma n. This integral is gamma function, gamma n, and here n greater than 0. So we will evaluate this integral using gamma function, 0 to infinity e to the power minus x, x to the power n minus 1. So first, take anyone, e to the power minus x square equal to p, because you know that here e to the power, you know e to the power minus x dx equal to what, but you don't know e to the power minus x square dx equal to what. So it is taken a transformation, x square equal to p. So 2x dx equal to what? Dt. Dx equal to what? 1 by 2 root 2 dt. So this integral 0 to infinity to the power minus x square dx equal to what? Half 0 to infinity e to the power minus t e to the power half minus 1 dt. So if you compare with this integral 0 to infinity e to the power minus x, x to the power n minus 1 dx, that is equal to gamma n. So here it is half, half means half minus half. So it can be written half minus 1. So if you compare this integral with this integral, it will be gamma half. And you know that gamma half equal to what? Root 5. Gamma half equal to root 5. So here it is root 5, and there is a half, so root 5 by 2. Similarly, this other integral also root 5 by 2. So this integral equal to root 5 by 2, root 5 by 2, that is 5 by 4. If you have any question, ask me. And I assume that all of you have knowledge on beta gamma function because it is in your syllabus also. As I could check, just a minute. Yes, there is improper integral. convergence, Cauchy principal value, beta and gamma function, and their properties, relation between beta and gamma function. And I think already it is completed. So this integral is clear.
Yes, sir.
Yes, sir.
Yes, sir.
So if any times you found that e to the power of something, say x, if it is x into y, then you cannot separate it. But x plus y or something other, then you will do in this way so that you can separate two integers. It will be easier to evaluate. That's why I am discussing all possible ways so that there is confusion. Okay, this is one
Sir, hello, sir.
आ रहे हैं सर, चले गए।
सर क्या?
फिर से
भाई
आएंगे
वो
कनेक्शन।
वो फाइनल करके गए तो भाई टेस्ट एंड ऑल लाइक चले गए पहले ही।
हाँ हाँ हाँ।
हाँ हाँ फाइनल
अरे
वही सिलेबस रहा। पहला में जो सिलेबस था वही रहा। ये पीडीएफ तो सर अभी नहीं भेजे जो अभी पढ़ा रहे थे।
नहीं नहीं, अभी नहीं भेजे।
भाई वेट करेंगे क्या? बिकॉज क्लास का टाइम तो अभी है।
हाँ वेट करो।
आने वाले हैं सर, वो
अच्छा।
कनेक्शन शायद लॉस्ट हो गया होगा, इसलिए दोबारा आने वाले हैं।
हेलो सर।
So I think I was disconnected.
यस सर, यस सर,
यस सर।
यस सर।
Okay, no problem. Again, certainly I was disconnected. Frequently happening this one. Okay, so cards region of integration is bounded by xy equal to 1, y equal to 0, y equal to x, and x equal to 2. So do you know this card xy equal to 1?
यस सर, रेक्टेंगुलर पर
What is the name?
हाइपरबोला, रेक्टेंगुलर
Huh?
हाइपरबोला,
Rectangular
रेक्टेंगुलर
hyperbola, yes.
रेक्टेंगुलर हाइपरबोला।
Usually its form is xy equal to c square, here c square equal to 1. So it is a
1।
rectangular hyperbola. Okay. So you know this curve and also know the shape of the curve. Here, this is the curve xy equal to 1 and y equal to 0. Y equal to 0 means x-axis. Y equal to x, y equal to x this line, and x equal to 2 this line. So the region of integration is the shaded region as shown in the figure. This portion, this. Now look at this. This is the region of integration, this portion. Now you have to set the limit. Here are uh, here are x square plus y square dx dy. Would you tell me any idea to evaluate this integral? Here, look at this. Up to this, here this curve y equal to x and this xy equal to 1 intersect at the point 1, 1. If you consider a line here, then we are getting actually two regions. This region is R1 and this region is R2. Why we are dividing two regions? Because if you consider that R1, R2, then for R1, y varies from any point on this line to this. That is, y varies from 0 to x and x varies from 0 to 1. And any point here, y varies from 0 to 1 by x
1
and
by
x
x.
varies from 1 to 2.
2.
Clear? Hello?
Yes,
Yes.
sir. 1 to 2.
So it is divided into two regions, R1, this region, left hand side region R1, right hand side region R2. Here for the region R1, if you take y first, then y varies from 0 to any point on the line y equal to x, that is y equal to x. And if you consider any point in the line R2, sorry, in the region R2, then y varies from 0 to any point on the curve, that is y equal to what? 1 minus, 1 by x, that is written here. Look at this. R1 union R2 means it is this one. And I told you that if any region is divided into two regions, R1 and R2, then this integral equal to the sum of the two different integrals, one evaluated at R1, another evaluated at R2. So now it is not so difficult. In the first region, y equal to 0 to x equal to 0 to 1. In the second region, y equal to 0 to 1 minus x equal to 0 to, 1 to 2. And then just integrate you can do it. It is not so difficult. If you have any question, you may ask me. It is divided into two regions because because in the first region y varies from 0 to on this line, that is x. In the second region y varies from 0 to on this curve, that is 1 by x. So you cannot do it in a single region. So I think it is clear to you. So go to the next problem. Go to the next problem. First, try to understand the problem. Don't check the solved question. What is written here? Evaluate this one. Sorry, evaluate this one over the domain bounded by the parabola y equal to x square and y square equal to x. Can anybody tell me what is the meaning of dx dy? This. What is the meaning of this?
Sir, area.
Yes,
Sir, dx dy is the area, right?
area. Yes, area of the region in the R. Area of the region R. Actually, this means this is the area, total area of the region R. So here actually this integral means this is one application of the double integral that when you are evaluating this, it means that you are actually evaluating the area of the region. And this region is bounded by y is equal to x square and x square, sorry, y equal to x square and y square equal to x. One is the parabola is this, another is the parabola is this. So this is the common region bounded by the two parabola, and you have to find the area of that region. Area of that region. Try to evaluate this. Try to understand first. Integral is not so difficult. First evaluate this one. Here actually, suppose if this is one curve and this is another curve, you have to find the area of this region. So what you have to do, what you have to, what you have to do, if you take any point on this curve, then y varies from here to here. Here also y varies from any point on this curve to any point on this curve. So y varies from y equal to x square to y square equal to x, that is y equal to root x. And x varies from here to here, this point. This point is what? 1. So
Sir, 0 to 1.
y varies from x square to root x and x varies from 0 to 1. If you ask me that why we are not taking x first then y, then also you can do it, no problem. From here to here, then y varies from 0 to 1. You will get the same result. This is the area of the region bounded by the y equal to x square and x square equal to y. If you have any question, first ask me, then I will go to the next problem.
No, sir, it's clear.
Yes,
Yes,
Sir,
sir.
no questions.
it is clear.
Clear.
Sir,
Yes,
understood, sir.
Yes,
Yes,
sir.
sir.
Okay. So next move to the next one. Okay, next another integral. First try to here look at this. This integral is little integrand is little different, not simple root over of 1 minus x square minus y square, root over of 1 plus x square plus y square over the positive quadrant of the circle. So here also you can set the limit y equal to root over of y equal to 0 to root over of 1 minus x square. Y equal to 0 to root over of 1 minus x square and x varies from 0 to 1. But look at this, this integrand is little complicated. Root over of 1 minus x square minus y square by root over of 1 plus x square y square. So in this case, you can evaluate in this way, y equal to 0 to this, x equal to 0 to this. But when you will integrate this function, then it is not so easy. So that's why, and as it is a circle, x square plus y square equal to 1, we have given a transformation x equal to r cos theta, y equal to r sin theta. And in this case, you know that the Jacobian is r and theta varies from 0 to pi by 2 and r varies from 0 to 1. But our main aim is to evaluate the integral so that it becomes convenient to evaluate the integral. So if you choose x equal to r cos theta, y equal to r sin theta, then this equal to what? R dx dy equal to r dr d theta into r, and 1 minus x square plus y square, 1 minus r square, 1 plus x square plus y square, 1 plus r square. And here r varies from 0 to 1, theta varies from 0 to pi by 2. Both limits are independent limits. So here it is, theta is separately done, r integration of this one is separate. Now you know how to evaluate this type of integral. Here it is r square equal to cos 2t and r equal to cos 2t. So the integral, because it is a function of now single variable, so you can evaluate your knowledge of definite integral. Here it is d theta, so theta and 0 to pi by 2, that is pi by 2, and this portion is to be evaluated in this way finally. So here the region of integration is simple. It is a portion of a circle. You can easily integrate, but the integrand is little bit complicated. That's why it is better to use the transform x equal to r cos theta, y equal to r sin theta. Otherwise, if you can set root over that I told you, y varies from 0 to root over of 1 minus x square, x varies from 0 to 1, then also you can do it. But if you think about this portion, then it will be difficult to take it. If you have any question, why in this case transformation is so important. Okay, then go to the next one. Here it is one example to change the order of integration. Look at this, then I will explain. Okay, so here look at this. Change the order of integration and have change the order of integration and hence evaluate the integral. Here e to the power x to e means it is a limit of y because it is function of x. Sorry, limit of y. Y equal to e to the power x to e and x equal to 0 to 1. Even it is not given here which one is the limit of x, which one is limit of y. Still you will understand that this limit is for y and this limit is for x. But you have to change the order of integration. Means you have to first draw the region of integration, then change the limit. E to the power x, y equal to e to the power x, you know this is the curve, y equal to e to the power x, y equal to e means it lies between 2 and 3, so it is a line, this one. And x equal to 1, this line, x equal to 0, this line. X equal to 0, this line, sorry, this line. So the region bounded by all the curves is this region. And here it is first with respect to y, then with respect to x. But you will have to do first with respect to x, then with respect to y. So what you will do? So what we will do? First with respect to x means x varies from here to here. X varies from here to here. That is, x varies from 0 to this curve, y equal to e to the power x. That is, x equal to log y, x equal to 0 to log y. And y varies from 1 to e, 1 to e. Now integrate this one, first with respect to x, then it is nothing, it is very simple to evaluate. But if you could not find the case of the region of integration, then it may be difficult for you to change the order of integration and hence to evaluate. Is it okay? Or if you have any question, you may ask me.
Yes, sir. It's so.
Okay. So the all possible ways change of order of integration, transformation of variables, area of the bounded region, etc. I have discussed. Still, it is you remember that you have also to practice.
Sir, this PDF you will share in classroom.
This is not fair.
No, sir.
It's not.
No, sir, this PDF is not.
No, sir.
Okay. No problem. I will share it today. No problem. Earlier one is shared, na?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So today I will share this one.
So
And
till that, sir,
that
one
one?
fourth circle.
Huh?
Till that, sir, one fourth circle, sir, x square plus y square equal to 1. Till that problem, it is shared.
I could not understand why I am hearing so low voice. What you are telling?
Sir, in the last PDF you shared, that was the, sir, one fourth circle. That problem was the last problem in that PDF.
Okay. So this PDF is not shared anyway.
Yes,
Okay.
yes, sir. Yes.
Okay. I will share it. No problem. Oh, I understand. Then later I extended it. Maybe there are two problems or something like that.
Okay,
Okay,
sir.
today I will share it. Okay, that's all for today. And remember that in the next Wednesday, uh, I must take the class test.
Okay, sir. Sir, will it be
Okay.
from
Sure,
9?
sir.
The same syllabus that I told you earlier.
Okay, sir.
Thank you, sir.
Questions are not so
Yes, sir.
difficult. Why you are not? Okay.
Thank you, sir.
Thank you, sir.
Thank you,
Yeah.
sir.
Just a
Thank you,
moment.
sir.
What's the one? What's the one?
Then the exam is on 16th.
बिल्कुल